Theorem. Let x equals to xn be a sequence of positive real numbers such that limit n tending to infinity पे xn plus 1 upon xn which is equals to L which is greater than 2 L, right? So if the sequence limit xn sequence limits L which is greater than 2 1, then x is not bounded. Okay, x equals to xn is not bounded. If it is not bounded, then it is not convergence. Okay, now we have 3 points on this theorem. Okay, firstly, this is if the sequence limit L is greater than 2 1, then x is not bounded, so it is not convergent, right? If L is less than 2 1, then the limit exists and the limit of xn is equals to always 0, so it is convergent. Now if L is equals to 1, right? If L equals to 1, the limit of xn plus 1 upon xn which is equals to L which is equals to 1, so either it is convergent or divergent. It does not gives you the proper test, so either it is convergent or divergent. So there is other test where you have to find out for if there exists the limit L is equals to 1. If there will be the limit L equals to 1, so either it is convergent or divergent. So you have to find out the other test to see what is the sequence limit. Okay, now if we have first test, xn is equals to 2 to the power n which is equals to 2 to the power n plus 1 upon 2 to the power n. So limit n tending to infinity 2 to the power n into 2 which is upon 2 to the power n, right? Now after cancel outing it, it is equals to 2 which is greater than 2 1, so it is an unbounded sequence. What is unbounded sequence? If it is unbounded, then it is not convergent, right? Now xn second term, xn equals to n upon 2 to the power n, then it is n plus 1 upon 2 to the power n plus 1 into 2 to the power n upon n which is equals to 1 by 2 n plus 1 upon n. So after taking limit L tending to infinity, this term goes to 1 and only this term is left. Now it is less than 2 1, so it is convergent and the limit exists. And the limit exists and the limit of xn is equals to 0. Now for the third, if xn plus 1 upon xn 2n xn, if you take limit to x, if you take sequence 2n, then the limit of this is equals to 1 and this sequence is divergent. How do you say that? As the limit of this sequence is n tending to infinity is infinity, then it is not a convergent sequence, right? Because of